Hello and welcome to our Presto training series. I see that the floodgates have opened and Mandy's letting everyone in. So we are still going to be giving you a minute for everyone to join. We have 100 and something people online at the moment. We don't want to keep you too long. So let's give it another minute and then we're going to start our training series. Part 1 this time with David. Martine and Dane are our next victims that I've roped in to train us all and teach us all the cool features in Presto. But today we're gonna see what David has to teach us, and I know there's gonna be a lot. So hold on tight. It's gonna be a fun ride. In a minute, we'll get rolling. In the meantime, of course, as you see, PrestoSQL.io is our website where you can download Presto and all kinds of stuff like that. If you've registered, you also saw the email how to install Presto and so on. Don't worry about that today now, though. We'll talk about all that shortly. What do you reckon, David? Should we give it a shot? Let's do this.
Let's get started.
All righty. All right. Okay, everyone. Thank you very much for joining us in our Presto training series, session 1 today, where David, one of the co-creators of Presto, is going to teach us more about the advanced SQL features in Presto, which will astound you. That's pretty powerful stuff there. So hold on for an interesting ride. Want to go to the next slide, David? My name is Manfred Moser. I'm a developer, author, and trainer at Starburst. I've been an open source hacker for a long time. Wrote a couple of books. Just recently, I finished the Presto the Definitive Guide, and I hope you all get a free copy from Starburst already. If not, make sure you get that. I've been doing lots of trainings in the past, and today the person that's training is going to be David, who is a co-creator of Presto. So he's been in Presto from the beginning. He knows it ins and outs like no one else, and he is a founder of the Presto Software Foundation and also now CTO at Starburst, leading us all into a better world with Presto becoming faster and faster, more and more powerful. And today we're going to learn about these advanced SQL features. So today I'm going to give a quick review of Presto. Hopefully most of you already know what Presto is. And then David is going to dive into general SQL features using JSON format data and how to work with that, since it's pretty prevalent in a lot of storage backends that Presto supports. We'll talk at aggregation techniques with SQL, and then we'll have a little bit of a break because that's going to take us already for close to an hour to get there. After the break, we'll talk about array and map functions, window functions, and during the whole session, we'll also take questions. So in the end, we'll have a dedicated Q&A session as well. Want to jump to the next one, David? In questions in general, please do ask questions anytime. You ask questions by using the questions feature. David can show you what that looks like on the slides. You see there is a questions feature right there. I will sort of collect those questions, see which ones are necessary to be answered straight away. Most of them will probably collect at the end, and in the dedicated Q&A and breakout session, we'll try to answer as many of them as we can. We'll see how many there will be able to answer. Obviously, there's lots of people on today, so we might not get to all of them, but that's okay. Now, in terms of the class attending today, here's some advice. This is a fast-paced overview. David knows his stuff quite well, and he's written all the queries up already, so you won't be able to follow along. Don't do that. It's gonna just take your attention away, and you're not gonna be able to follow what's actually being taught. So instead, just focus, pay attention. This is an advanced SQL class. So in order to learn that even better in practice, of course, afterwards, you can use the demo video that we sent out that allows you to set up Presto and the CLI locally. The TPCH dataset is pre-configured in that, and then you can learn at your own pace. We will make the video recording and the slides available for you so that you can then slowly step through the video, type out the queries, copy them from the slides, try it yourself with the TPCH dataset, but then also apply them to your own skills to your own data sets and your own use cases. So hopefully you'll be able to, with the course of the material today and then what we present, what you make available afterwards, learn a lot. But this is going to be a fun ride today. So just before we dive into the advanced SQL stuff, just a quick overview for those of you that are new to Presto. Most of you probably know about Presto already, but I'm going to give you a quick recap. So what is Presto? Presto is a high-performance ANSI SQL engine. So it is a distributed query engine. It supports SQL as the query language for all sorts of connected backends. It has a cost-based optimizer, and it's proven to scale horizontally in massive clusters up to many thousands of machines, many hundreds of thousands of users. So it's very, very powerful to query your backend data with SQL, which is why, of course, in our class today, it's going to be very important. Do you know what SQL is supported? It's an open source project that has been around since 2012. It has a very active, large community, large companies, small users, big Fortune 100 companies. Everyone is using Presto, and there's also a huge variety of use cases and users. There's different connectors and so on. You can find out about it all in prestosql.io, our website. Presto allows you to separate the compute and the storage. What we mean by that is the database that's being queried, or the file system, HDFS or whatever it is, some cloud file system, is going to independently sit there, and Presto can query directly in those target systems, and the compute processing power for that scales separately. So your Presto cluster can be completely switched off while the database sits there, and it can be scaled up tremendously to have the heavy analytics loads of your users during lunchtime or whenever they are very active, right? And all of that is possible without ETL usage, because the queries run straight into the underlying data systems. Presto can be run pretty much everywhere. There's no lock-in in terms of what cloud you run this in, what storage engine you query, what Hadoop distribution potentially is being queried with the Hive connector, or also what database you query. There's no lock-in, so Presto is just allowing you to have one system to run queries into all of them. You want to go to the next one? Just a few advantages of Presto. Why do you want to use Presto? Well, it's super fast to get to insights, to understand what's in your data, because you can query, you can set up Presto and query the data straight away. It's pretty easy to get Presto started. You can scale it tremendously, and you directly query the systems in place there. So there's no ETL you need to do, no moving things around. All you need to do is configure the catalog to connect to it. That automatically leads to lower costs. You can avoid this processing. You can run the computes when queries are running and not when they're not needing to run. And you can have one data consumption layer for all your different backend systems, which means it makes it easier for your users to query any data, because they know they just go to Presto, and then it doesn't matter if the system is in HDFS or in some cloud storage or in Elasticsearch or in your Oracle database. They all can just use Presto and the advanced SQL features that we're going to learn today, or some BI tools that, of course, also use SQL. And all of that is possible with Presto. So if you haven't tried Presto yet, you do want to give it a roll. And if you already know about all that, that's excellent. Now is your time to learn more about the advanced SQL features with David.
Thank you, Manfred. So we're going to learn about various Presto SQL features today. I picked out things that I thought were interesting and useful for people to use. There's actually a lot more things I wanted to present, but just due to time, we wouldn't have time to present everything. For all of these areas, especially like aggregation functions, window functions, etc., if you read through the Presto documentation, you'll find a lot more related functions and interesting stuff that you can use. So this is just intended as like an overview to kind of show you like what's there and get you thinking in the right direction, and definitely encourage you to dig in and play around on your own. So these general SQL features that we're going to start with are kind of foundational, and we'll use them throughout the rest of the presentation. And they're also just like generally useful in a whole bunch of situations. So the first thing we'll talk about is the format function. You often have like numbers or dates or strings that you want to format into a string in a specific kind of way in your output. So like maybe you're creating a report and you want to show a number in a certain way. The format function can let you do that. So if we look through these examples here, the first one, we've got the pi function in Presto, which just returns the value of pi. And we say pi equals, and then %.5f. This is a format specifier. The dot means to put a decimal point in here, and the 5 says to format it with 5 decimal places, and the f says to format it as a floating point number. And we can see that it outputs pi with 5 decimal places. Similarly, this %03d says the 0 says format with leading decimal digits and or leading zeros, and the 3 says to format with minimum of 3 digits. And so we can see it says 007 here. Another one is you often want to format big numbers with commas, so you can use % comma to format something with a comma, especially helpful like when you're printing monetary values. You can use -7 here says to print a trailing spaces, and %7 here says to print leading spaces. So we're going to print the string hello world with 2 trailing spaces and then world with 2 leading spaces. Another thing you can do is you can specify which of the arguments that you want to print. So we saw with hello world here, we've got 2 arguments and they're printed in the same order that they are in the arguments. But sometimes you want to format things in a different order than you're passing the arguments to the format function, or you want to reference the input multiple times. So we can see here that the arguments come in order A, B, C, but we said we want the second one B, we want the third one C, and the first one A. So they come out in a different order. And then we can also format dates where we've only passed the date into the function one time, but then we format it multiple times by referencing the date argument multiple times here. And then we can print the date with the day of the week and then the month of the year as a name. And you'll definitely want to read the documentation to learn about all the different ways that you can use the format function, but it's really powerful and really handy when you need to format some values in a report. So case expressions let you do conditional logic and return different values depending on what the input is. And there's 2 different forms of it. The first form is the simple case. Oh, whoops, I missed the slide. Yeah, the first one is a simple one where you pass in a value and then you just say when the value is equal to something, then you return a different output. So here we're saying we've got a table with numbers 1 through 4, and we're saying, okay, when column N is 1, then we return the string 1. When it's 2, return the string 2, and when it's many, we return the string many. And you can see that's what we get in our output. And then the other form of it is more generic, where instead of passing in a value on the case keyword, the when conditions are arbitrary expressions. So we can just say when n equals 1, then do this. When n is n, this list of values, do something else. And then we could have any number of when expressions here. It's important to note that the when expressions are evaluated in the order that they appear in the case expression. So sometimes you might have overlapping conditions where if we had a when n equals 1 down here again that returns something else, it wouldn't be evaluated because we stop when we hit the first match in the case expression. And then we can see the output of the query is as we expect from the case expression. Similar to case, we have an if expression, and the if expression takes a Boolean expression to evaluate, and it takes something to return when it's true and something to return when it's false. And we can use the if expression here to pluralize some values when we're printing. So if we want to print out the phrase like I have 0 cats or I have 1 cat, or I have 2 cats, etc. So that we only want to print out, we want to make it plural when we want to make it singular when there's 1 item. We want to make it plural every other time. So we can say, if n equals 1, then it's singular. We don't print an s. Otherwise, we do print an s. And then we can plug this back into the format expression, or the format function that we showed earlier. And then we get this output. And so you can do some really powerful like formatting in your final output, like with a combination of if and case and the format function. Now, often when you're running queries, you'll be processing bad input data where like most of the data is good, but a few of the input rows are not as you expect. And normally, Presto will fail the query whenever you hit bad data because Presto's designed to always return correct answers. Like we feel that returning a correct answer is of utmost importance for a database because people have to trust the results. But sometimes you know that like your data is a little bit dirty and you want to just keep going, and that's where the try expression can come in handy. So normally, if you divide by 0, the query is going to fail with division by 0. If you're trying to turn something into a number, like you've got some like a string column, but like you know it's a number, you'll turn it into a number. But if it's not if it can't be turned into a number, then you'll get a failure. Similarly, anytime you're doing math operations in Presto, if it overflows, the query will also fail. Some other systems will wrap, but per the SQL standard, the query has to fail with an overflow error to guarantee that you always get the correct result, or you know that the query can succeed. However, if you want to keep going, you can wrap the expression using the try expression. So if we wrap the division by 0 or the bad cast or the overflow and try, then we end up getting null, and the query will keep going. And you can use like case or coalesce to turn those nulls into some other kind of default value if you want. Now, it's important to be careful with the try expression because whatever it's wrapping, it'll suppress any errors for the entire thing. So if you have like some deeply nested expression and you wrap the entire thing in try, if you get an error like way inside the deeply nested expression, you might not be expecting, it might not be an expected error. Maybe you're expecting the error on the outside, but any error, no matter where it happens inside expression, is going to get caught. So you just need to be mindful that when you're using it, what the behavior is going to be. So Presto has this concept of Lambda expressions. You'll find those in more modern programming languages. Lambda expression is a way to basically write a function inline and then pass it into another function while it get applied over your data. And Lambda functions, there's 2 forms. There's the form for 1 input and there's a form for multiple inputs. The Lambda expression has the inputs on the side, and then there's an arrow, and then there's the output expression that's going to be evaluated using the inputs. So if you have the Lambda expression with multiple inputs, you have to put parentheses around the input arguments. If you have a single one, you don't, although you could use parentheses as well if you want. And we'll see how these are used later. Okay, so now we're going to talk about using JSON. JSON is really common, especially like when you're processing like log data. Maybe you've got like, you're collecting logs and loading them in S3, and then you need to extract your data out of this JSON. And JSON can be difficult because you don't always know what the schema is going to be, and sometimes it can be mixed where it doesn't have a consistent schema. And Presto's got a lot of functionality that lets you be able to take advantage of the JSON data that you have. So the first thing to know is that Presto has a JSON data type. And a JSON data type is similar to a string. You can kind of think of it as just a string containing JSON, except that the data inside of it has already been parsed and is already known to be like well-formed JSON. And it's also a little bit different semantically in that JSON has maps, and when you have a string with a map, the keys in the map can be in different orders. But in the JSON data type, the keys in the map are always going to be in a consistent order, and two maps of the two different JSON data type values with maps, even if the keys are in different order, this will compare the same. So if you have logically the same map, no matter what the order is, they're treated as the same value. And that's important if you're doing like a comparison or like an aggregation where you group on it. So the JSON parse function takes a JSON string and then turns you a JSON data type. And an important one is null, because JSON has a null, and you'll get a JSON data type containing the null, which is different than a SQL null. And you can actually check to see, is this a JSON null? And you do that in a different way than you check if it's a SQL null. We can see here an example where we've got an array that contains a string, it's got a number, and then it's got a map. And we can see that the map has two keys, X, Y, Z, and ABC. We can see that X, Y, Z in the input comes before ABC, so the keys are not in order. And after we parse it with JSON parse, we see that the keys in the map are in order. So if we parse two different maps with the keys in different order, but they actually have the same contents, then that's how you end up with the same JSON data type and how they'll compare the same. And all of the JSON functions in Presto, they take the JSON data type. Although if you pass a string, it'll be implicitly parsed into JSON.
That's an interesting question, David, regarding to JSON, and that is, what's the difference of JSON and SQL null?
They're two entirely different things. So null is just another JSON, is just another value. Sorry, a JSON null is just another value, just like a number or an array or a string. Whereas a SQL null is the same as, SQL nulls are special, and they work like very differently in SQL as they do in like other programming languages, where like any operation on a null basically gets turned into a null, so they're completely different than JSON nulls.
That also has effects on when you do Boolean expressions with nulls, right? From what I remember.
Yeah. I'm actually not really talking about nulls at all in this presentation, because that's actually a whole, you could probably do an hour presentation just about how nulls in SQL work and all like the pitfalls. But anyone dealing with nulls, like you definitely want to read up on that. Anytime you get weird behavior in SQL, it probably has to do with nulls. That's just kind of how nulls in SQL never work the way people think they do.
That's a good tip, thanks.
And if you search on the internet, you'll find lots of like tutorials and like presentations about like how nulls work in SQL. And the Presto documentation has that as well. So the JSON extract function is used to extract values from JSON data type, and it takes a JSONPath expression that lets you dig into it using this special dotted syntax. So a JSONPath like starts with a $, and then you have a dot saying extract this key from the map, and then similar here, you say extract this key, and then if this is an array, return the first element, and if this is another map, return this item here. So if we look at, we've got a JSON value here that is a map. It's got a single key languages. The value of that is an array, and then inside of that array is map elements where both of them have a name key. So if we just say extract the languages field from the map, then we get the inner array that has the two maps inside. Or if we say extract languages and then extract the first element from the array and then extract the name, then we get the string Java here, because that's the name field from the first element in the array. Now, there's two different JSON extract functions. There's JSON extract, and then there's JSON extract scalar, and those two things return different things. So JSON extract returns the value as JSON. So we get back, see this double quoted string is a valid JSON string. So you could actually take that, turn it back, like give it to anything that's expecting JSON. See if we same here, where we extracted the array, we see that it's an array with brackets. This is the fully valid JSON string. JSON extract scalar extracts a scalar value like a Boolean, a number, or a string, and gives it back to you as a string value that's not valid JSON. So we can see that here we extracted the name Java, but there's no double quotes because we're extracting it as a scalar string value, not as JSON.
So then you can cast it afterwards, can you? Like
yeah,
if you
so if you were extracting a number, you could then cast that like to a big int or a decimal type. And you want to use JSON extract when you're like nesting that with other JSON processing, and you want to use JSON extract scalar when you just want to like extract a value like a number out of your JSON. So another thing you'll want to do is when you have a JSON value, you'll often want to cast it to a more structured SQL data type so that you can use normal SQL functions to process it. So we can see that we've got the same JSON that we had in the previous slide. We've got a map with one key, and then inside of it's an array, and then inside of those are maps. And with the key is always a varchar, or it's always a string, because JSON keys are always strings, and then the value is always a varchar. So we can cast this to a map with string keys, where the value is an array, and then the array contains maps of string to string. And we can see that the cast worked. We get this back out as a Presto data type, and then we can use this with any of the other like SQL functions that operate on like arrays and maps. Now, one thing that is complicated about JSON is that the different, it doesn't have to have a consistent structure. So we can see here, we've got a similar JSON structure to before. We've got a map of an array of a map, but inside this, the inner map, we've got this is a number, this value is a string, this value is an array. So there's no SQL has strong typing, and there's no data type that can represent like both a number, a string, and an array. You can only have a type that has one of those. So there's no way to do a simple cast of this to a Presto data type, because there's nothing that can represent what the value of the value of this map. So what we can do is we can cast it to a map of a string to array of map. Now for the value, instead of it being varchar like it was in the previous slide, because all of the values are strings, we actually cast this to JSON. So we call this a partial cast, where you're casting the outer part to a SQL data type, but the inside of it, you're saying, well, there's no SQL type that can represent this, so I'm going to leave it as JSON. And then you could you could process the outer part of it using standard SQL functions and operators, and then process the inner part later with more JSON functions. And this is a pretty powerful technique, like say when you're processing log data where the format of it has changed over time. You need to be able to deal with the changing data types inside. And then we can see that we get the cast works. We get an array with a map where the inside of it is JSON. And you can also cast to rows as well, would be another way to handle this. And you can find an example of that in the Presto documentation. So if you know that all of the keys always have the same value for the same named key, you could actually cast this to a row type in Presto. Another thing you'll often want to do is when you have a JSON data type, you'll want to turn it back into JSON. So we've noticed in these previous examples where we select out the JSON data type, it's rendered in the CLI or in other tools as JSON, but it's actually the JSON data type. It's not a string. So sometimes you need to turn it back into like JSON so that you can pass it to another function, or you can do some more string manipulation. And the JSON format function turns the JSON data type back into valid JSON. And that's all the JSON data types we're talking about here. Definitely recommend reading the JSON data type section in the manual. It's got a lot more examples of things that you can do. But hopefully this gave you a taste of like how to process JSON data.
Just a quick chat about JSON before you jump on, David. I think it's worth noting that JSON is very, very prevalent because of it being used as a data format in lots of web technologies. And it's important to understand that lots of data sources that Presto supports will be coming in contact with JSON files. And there's different support for them. One system, for example, that I found very amazing when I wrote the book is the Elasticsearch connector, for example. On the one hand, you can use all that and you can get access at the source like payload that Elasticsearch brings back. But on the other hand, what it actually can do is it unwraps all that stuff to plain tables and everything for you. So you don't even need to do all that. And that's pretty amazingly powerful. And the Presto SQL Elasticsearch Connect is a good example for doing that. And that can be very, very helpful. So when then that fails, you can jump back to those JSON format functions. And that's really nice. And of course, other connectors that don't support something like that yet, or where you just like working with pure files being returned from your object storage, so they will basically allow you to process that stuff nicely with all that function. But as you can see, it can get a bit hairy, but you're all up to it, I'm sure.
Yeah, that's a great point, Manfred. That if you're stuck with JSON data, like the stuff in Presto will help you process it. But if you can avoid JSON, or you can turn it into structured SQL data types, like say during your ETL data loading process, you definitely want to do that, because JSON's both expensive to work with, both in terms of processing power and in terms of humans working with it. Like as you saw, like it's way harder to work with JSON than it is to work with SQL data types. So if you can do the work once to turn it into nice SQL data types, like that makes it easier for everybody.
Yeah, and you could use even Presto for that, right? Like you could have a federated query that does a create table as, selecting it from one data source where it is being in JSON, you format it on the fly and dump it into a relational database and then query it from there.
Absolutely.
That's pretty nice.
We're going to talk about advanced aggregation techniques. So I'm sure everyone's familiar with basic aggregations like group by and you like count and sum and those sorts of things. We're going to talk about a little more powerful things that you can do with Presto. So one thing you can do is pass the distinct keyword to aggregation functions, so that the aggregation functions only sees the distinct or the unique input values. So if you have an orders table and you want to say, how many unique customers do we have? You would say count distinct of the customer key, and this gives you the number of unique customers we have. Now, this is a very common thing that people want to do, and this will give you the exact answer, but it can take a lot of processing power, and it's memory intensive because Presto has to collect all of the unique items. And if you have like some massive tables with like billions of unique items, like that can be like quite a bit of memory. So there's another way to do it. So if we want to do this operation faster and more memory efficient, we can use the Approximate function. So this will tell us approximately how many distinct customers do we have. And we can see that the previous answer was almost 100,000, and this one's like 101,000. So that we have an error of 1.66%. So if you, maybe that's good enough for you. And for a lot of cases, you just want to know like approximately what it is. Approximate will get you that answer much quicker and with less memory. You can read in the documentation about Approx_distinct that the function produces a standard error of 2.3%, which has a very specific statistical meaning. It means that over all inputs, the error distribution is 2.3%, but there's no guarantees of the exact error for any given data set. But if you're doing statistical work, this will have meaning for you. Approx_distinct uses a standard hyperlog-log algorithm that's used in a whole lot of systems to do this sort of unique value approximation. It's important to note that the error of the hyperlog-log algorithm is dependent upon the number of unique items that are passed into the function, not the total number of values. So if we call the Approx_distinct, if we use the distinct keyword here, so that Approx_distinct only sees distinct values, we would get the exact same answer. So maybe there's 1 billion input items and only 1 million distinct ones. You still get the exact same answer out of this because the error depends on the number of distinct items. And of course, you never actually want to do this because you're paying the cost of distinct and you're getting an approximate answer. This is just to show you that the error is over distinct items. Another approximate function in Presto is approx percentile. So a percentile is if you arrange things in order, and then you say, what item is 25% way through the list, what's 50% the way through, what's 75%, and so on. So the 50th percentile is the item that is in the middle of the list. Now, computing exact percentile is really expensive because you actually have to order the entire set and then find the item at the exact position that you're looking for. But the approx percentile function will give you something that's pretty close. So if we say, we run this query, what's our average order price? And then what's the order price in the exact middle? And we can see that the average is 151,000, and then the one at the approximately in the middle is 144,000. So we can see that they're pretty close, which means at least at the 50th percentile, we have a pretty normal distribution. You can also ask for multiple percentiles at once, and so you definitely use this. If you want multiple percentiles, use this version because it's efficient because the function can process them all at once. So we pass in the array of percentiles that we want. So if we say, what's at the 10th percentile, the 20th percentile, 50th percentile, and so on up to the 99th percentile, then we get back this array. So we see that again, 50th percentile is 144,000. At the 10th percentile, it's 39,000, and at the 99th percentile, it's 366,000. So you see that there's a pretty big distribution here in our data. Another thing that's common you want to do is you've got the max function where you're saying, what's the maximum price of all the orders? And so you can just use the max function for that. But another question you want to ask is which clerk what was the clerk for the order that had the maximum price? And so the maxify function lets you do that. So the maxify function takes the value that you want to return and then the value that you want to compute the maximum over. And so that we can see the clerk associated with the maximum total price was clerk 40. Now, another way that you could compute the max value associated with, or you can find a value associated with the maximum value of something else is to use a row type. So we can create a row type of total price and clerk. A row type is basically packing multiple values together, and then you can do comparison operations on it value-wise or column-wise within the row type. So if we do a max over a row type of total price and clerk, you can think of it as we sort the values first by total price and then by clerk. So that'll give us the same max price that we saw previously, and then also clerk will be next to it because it's part of it in the row type. And then we take the maximum, and then we do dot star, which turns it back into columns in our output query, and then we get the clerk that's associated with the maximum total price. And this works for some things, but like maxby is an easier way to write it. But there's other ways that, or there's other times that using turning things into a row can be useful. So the maxby function can also return multiple values at once. So if we say, what are the top 3 clerks associated with, or what are the clerks associated with the top 3 total prices? We pass in the number of values that we want maxby to return, and they're going to be ordered in descending orders. So we saw previously, clerk 40 had the maximum, had the largest priced order, and then these 2 clerks had the next largest priced orders. And another way you could do these in SQL is you could do like an order by limit, and that works, but that only works if if that's the only thing that you're doing in the query. Whereas you could use maxby combined with other aggregations, in which case like the order by limit trick doesn't work. So we've got a countif function in Presto, and a common thing that you'll want to do is you'll want to take your values and you want to pivot them so that you've got separate output columns for each group that you're aggregating over. So if we do a normal group by query, we say group by order priority, and then count the number of orders by order priority. We'll get 1 row for every order priority, and then we'll get, say, like 2 columns, 1 for the order priority, 1 for the count. But instead, if we want to have 1 column for each order priority with the counts associated with that order priority, we can do what's called a pivot, where we turn it from rows into columns. And countif is an easy way to do that pivot. So we say countif the order priority is 1, then we'll count all the values where the order priority is 1. If it's 2, we count the 2s and so on, and then we can see that we get 1 value for each column, or we get 1 column for each order priority with only the counts for that column. Now, another way to do this pivoting is there's actually a more generic syntax for it. So countif is a specialized function. It's if you're just doing counting, it's pretty short to type. But there's also a filter syntax for aggregation that's generic, where you say count filter, and then you say where some condition. And the aggregation function only sees rows that match that filter condition. And we see that we get the same output as we had in the previous slide with countif, using the more generic filter syntax. And this can be used with any type of aggregation. It doesn't have to be used for pivoting. There's actually like quite a lot of use cases for filter and aggregation. So we can see here we use the same filter trick on averages, where we want to say, what's the average price for each order priority? And then we could say average total price filter where the order priority is what we want, and then we also get a column of the averages for each order priority.
There was a good question that came in. I think that's worth discussing for a second, and that is Abdul was asking, how do you count distinct with countif?
You can't do it with countif. You would need to use the generic filter syntax. That's a good question.
Makes sense.
So countif is kind of it's a limited shorthand. That's like if you want to just count, if you want to count items where something matches, like it's short to type and easy to remember, but filter syntax is more generic.
Great.
It's a good question. So aggregating complex expressions. Remember we saw case expressions previously. When you use case expressions inside of an aggregation function, you can do some pretty powerful stuff. So if we've got our orders table and we've got the different priorities, and we want to ask if we charged a premium for high priority orders, like how much would our additional revenue be? So we can say the average of total price times, and when the order priority is 1, then we'll charge a 10% premium. When it's 2, we'll charge a 5% premium. Otherwise, there's no premium. And then we can divide it by the total price to see what the gain would be. The average price with no premium. And then we run this query and we see that like we'd have an additional 3% revenue, charging a 5 and a 10% premium for those high priority orders. And so another way to do COUNTIF is you could actually do a case expression inside count. And so it's actually similar to filtering, although there can be some differences. So like case is yet another like thing in your toolbox for if you want to do conditional aggregations or do some complex calculations going into your aggregation. Another thing that you often want to do is you want to take your aggregation values and you want to put them into an array. And so the array_agg function lets you do that. And so we have this region table with 5 region names. We want to say aggregate into an array. And inside the array, we want to order by the names descending. So we've got the M goes first, the E is next, and the A's are last. And while this is quite useful, it's important to be aware that like arrays are in memory. And so if you've got billions of items, you wouldn't want to use array_agg because you can't have an array with billions of items. You'd run out of memory. So just be conscious when you're using this, but it can be quite powerful. Now, previously we talked about Lambda expressions. And so Lambda expressions are a way for you to pass code or pass a function into a Presto function, and that Presto function can call it back, call your Lambda expression back for each value. And so the reduce_agg function basically lets you build your own custom aggregation functions in SQL using Lambda expressions. And so like SQL has the sum aggregation function, where you say, if you just add up all the values, what's the sum? But an aggregation function it doesn't have is a product function. If you say, I want to multiply all the values together, what are we going to get? And so we've got an input table here. We've got X's and Y's. We're going to group on, and that's the name column. We're going to group on that. And then we want to take the product of what's 1 times 3 times 5 and 2 times 4 times 6. And so we get like 15 and 48 as the product. So how the reduce_agg function works is the first argument is the value that we're going to be aggregating over. Just think of it as like, the sum function, you'd pass in sum of value. So reduce_agg, you're passing in the value. And the next thing we're passing in is what is the starting value for the aggregation? Since we're multiplying, we want to pass in 1 so that if you multiply 1 times something else, you get the thing that you're multiplying against. And now here we have the Lambda expression. So this Lambda expression is going to be called with either 2 of the input values or of the starting value and an input value. And so we have like the input arguments of the Lambda expression are A and B, and then it's going to return the result of A and B. And so the first time it's called, it's going to get called with 1 as the starting value, and then times the first input value 1, and it's going to return a 1. And then the next time we see the value 3, it's going to get called with 1 times 3, and that's going to be the output. And then it's going to get called with 3 times 5, and that'll be the output of 15. And then it's important to note that aggregations run across all the worker nodes in the cluster. So this reduce_agg function is going to run across, potentially hundreds of machines, and running this Lambda expression across all those machines, producing all of these intermediate values. And then at the end, we have another Lambda expression that says, how do we turn this intermediate value into our final result? And so since we're doing a product, we actually the intermediate value, we combine the intermediate values the same way as the intermediate values. The expression for the final result is the same as we compute the intermediates, but sometimes you'll actually want those to be different. And so you can actually pass in a different Lambda expression for the final output. But in this case, it's still the same thing. We'll take all the immediates, multiply them together to get the final product. And so this lets us write our custom aggregation function in pure SQL. And it's really powerful. It lets you do a lot of things that you just otherwise couldn't do, or that you'd have to write like custom Java code for in Presto as a plugin. But now you can just do it in pure SQL. Now this is kind of a random function that comes in handy sometimes, is the checksum function. Now, sometimes you're moving data between two systems, maybe like you export some data as a CSV file and then you load it in somewhere else. And you want to check and see that, do the tables in these two systems, do they actually have the same data? And that's where the checksum function comes in. So it's an order-insensitive checksum function. So it doesn't matter what order the data comes in, as long as all of the values are the same, you'll get the same output. And so you can run it over a single input column, like say, do the checksum of order key to see if these two columns in the tables have the same values. Or you can use a row, as we saw earlier, to pass in multiple values. So you can say, compute a checksum over the customer key, the order status, and the total price columns. And then it'll get a single checksum for all of those columns combined. And so if the checksum returns the same, it's highly likely that the two tables have identical data. I mean, obviously, this is a checksum, and so it's possible that two things that are different return the same checksum, although it's highly unlikely because it's a 64-bit value, but it's possible. If they return different, then it's guaranteed that they have different data. And so if you're doing a checksum over two tables and you expect them to be the same and they're not, then you have to do more complicated stuff to figure out why they're different. If you have questions about that, like post in Slack, it depends on your exact use case, what you do. There's various techniques. It's also important to note that the checksum function is not guaranteed to have the same output between different Presto versions. And so if you upgrade Presto and you run a checksum across the older version and the newer version, they might be different. They're usually the same, but be aware that it can change between Presto versions. It's not guaranteed to stay the same.
Could that also change based on Java version, or is it completely on the code base only?
It's completely on the Presto version. Two Presto versions are guaranteed to return the same checksum for any of the same inputs.
Cool.
Now, another thing you can do with aggregations is, let's say we're doing a count of, we want to count orders and we want to group them by order priority. So normally you just do that aggregation and this is what you get. You say, okay, well, along with that, I want to know what's the total number of orders that I have across, the entire table. Well, that's what the ROLLUP function lets you, or the ROLLUP operator lets you do for group by. So instead of saying group by order priority, you say group by ROLLUP of order priority, and now we get our normal output for each of the order priorities. We also get this extra column at the end here with order priority of null. That's the total. And so if we sum these up, and we get this total of the total number of orders in the table. You can use ROLLUP with multiple columns as well. So let's say that we're grouping by line status and return flag. We get our, we get the counts for how many items for each line status and return flag combination. But then for each line status, for each line status, we get the ROLLUP of what's the total number of things for that line status across all return flags, and we get this total here. And then also for line status of F, we get this total. For line status of O, we get this total. And so like we summed up, what's the sum of these? We're going to get this total. If we summed up the ends for the O line status, we get this total. There's only one return flag for O, so that's why there's only one. That's why this and this are the same, because there's only one combination of these two. And then we also get we also get the total for the entire table here. So we see that the total for the entire table is this. And so if we add it up like these two, we get this, because the S, the F, and the O, these two sums total to this. And so this is useful when you do a report, when you want to show like the roll-ups across the various different groups, and you want to get totals across the different levels. Now, similar to roll-up, we notice that we get, oops, so back to roll-up with multiple. What we didn't get was, we didn't get a roll-up of how many things matched, or for each return flag, we didn't say like how many, what's the total of all the ends across all line statuses. We only got it the other direction of what's the total of all the Fs across all return flags. And that's because we did the roll up in this order. We did it in line status return flag, which says do the roll up from left to right. Cube gives us all combinations of these, so that we have what's the total of all the Fs, what's the total of all the Os for line status, and then the other direction, what's the total of all the A's of the return flag, what's the total of all the N's of the return flag, what's the total of all the R's, and then what's the total across everything. And we'll see that cube gives you all the combinations regardless of what order that they come in. So it's you get more things than you do with roll-up, but it might not be what you want depending on what your aggregations look like.
There's some related questions there, by the way. Just quickly, Abdul is asking what the difference is between roll-up and a normal group by.
Yeah, good question. So a normal group, so if we did this with just group by order priority, we would only get these rows. We wouldn't get this null here with the total across all groups. And so that's what the roll-up gives you. It gives you that the extra group, the null group across everything. So roll-up is rolling up all of the group bys into an extra column that gives you the total across everything.
So the typical use case, if you like, what that avoids, I think, practically is that you don't have to run another query to get the total count. You get it all in one go.
Exactly.
Right? Okay. And then the other question is rollup just a syntax sugar? That's William is asking that. And is it translated into the equivalent group by so that it actually like basically does run two queries under the hood, or is this somehow further optimized in Presto, like actually doing it differently?
No, it's a great question. So it's actually optimized in Presto so that the input data is only scanned once. Like you could do a roll up manually by running a group by and then unioning it with a count query, but that would actually access the input tables multiple times. And importantly, not all data sources like guarantee that if you access the table multiple times, you get the same data, because like the underlying data set can change in between. Whereas rollup and cube guarantee that the input's only scanned once so that the result is logically consistent. Whereas if you actually did like a union and scan the input multiple times, you might get a total that doesn't match what you get if you actually just went and totaled the output of the other query.
Another like sort of like user-facing query related to that is if you can somehow rename the return value where it like returns null essentially or unspecified.
Yes, you could use coalesce to turn it into a different value, or there's also the grouping there's a grouping function that lets you see, especially in combination with like rollup or cube, where you've got different levels of rollups. The grouping function will tell you which one it is, and then you can use that to like assign it an appropriate name. I'm not going to show an example of that because it's pretty complicated, but if you look in the documentation for select, it gives you an example of how to do that. And related to like rollup and cube, there's the documentation is far more extensive than we're showing here. This is just giving you a taste of how it works. So definitely like read the documentation and learn about all the different ways you can use it. And so the last thing that you can do is grouping sets. And grouping sets is the generic, more powerful version of ROLLUP and cube. ROLLUP and cube create different groups, or it creates different grouping sets in your output. And grouping sets lets you just actually specify exactly what groups you want to return. And so we saw previously cube here generates, cube would generate these same grouping sets. So you've got an empty grouping set, which is group across everything. So that's like your total across all the groups or all the rows. You've got line status and return flag, which is grouping on both of these. So that's what like these are, is this grouping set. Grouping on just line status is this one here, where you've got the null and the return flag. And then grouping on return flag is this one here, where you've got a null for for line status. And the grouping function will tell you which one of the grouping sets these are, so that you can actually turn that null into something more specific that matches your data set. All right, and now it's time for our 5-minute break. If you want to stick around and like browse the Presto website or join us on Slack, you can also submit questions into the chat, and we'll try to answer them later.
Yeah, that was awesome, David. Thank you. I'm sure everyone is a bit exhausted now after this brain overload. A lot of good questions came in as well. So while you guys sort of jump out, we can maybe discuss some of them a little bit. One that came up multiple times is if you can do views. Hang on, let me see again in Presto. Let me see the exact question. Yeah, can we create a view in Presto and pass parameters to it? So my understanding is that like you can create views in the underlying RDBMS system or whatever, and then they get exposed as tables in Presto. But I think I'm not sure if there's much more.
No, views with parameters is pretty interesting. It's almost like a table generating function. That's something that I've often wanted myself, but we don't have support for that yet. But I can see that as a potential feature that we could add in the future.
That's awesome. I think in the State of Presto webinar, you guys also talked about how we're going to have, or you're working towards having more function support and that kind of stuff, right? So it might fit in with that at some stage in the future. So
yeah, that's actually kind of similar to polymorphic table functions. I guess they're not actually polymorphic because you know the schema, but it might be something that like the work to add polymorphic table functions might enable us to do like views with parameters.
Cool. We also got a whole bunch of questions about JSON related stuff. I think we're going to answer them a bit later in detail because there's a whole bunch of them. One is specifically also sort of related to JSON, but goes more into detail about a specific use case. And the user Anudeep is asking if it would be like what sort of like roughly the performance impacts would be when using the Redis connector with JSON-based like in terms of with JSON-based data. I think he's saying, what if I store something like org paquet in Redis compared to JSON? So I guess he's asking about the different data formats and how efficient they are to some degree in the different systems and the Redis Connect in general. Do you have any kind of higher level guidance there?
So I can talk about like in the Hive connector using like org parquet, which are highly optimized columnar formats versus JSON. I'd expect processing JSON could be 10 to 100 times slower, potentially. Like it really depends on what you're doing. Like you actually have to do a benchmark with like your specific data, your specific query, but JSON can definitely be far more expensive than having a having structured data types in an optimized columnar format. Another downside of JSON is that with JSON, you've got the entire string. And so like you've got to read that entire string off of like the file system or the object store. Whereas if you break it up into SQL columns and store in the columnar file format, you only have to pull off the columns that you're actually accessing. And so you can save quite a bit of network bandwidth and disk I/O on there, and on CPU for not having to process data that you don't need.
So it might be worth, if the data comes in as like JSON originally, to slot some sort of like create table as or some other transformation in place before you do lots of heavy analytics on it.
Yeah, my understanding with Redis is more of a key value store, so you don't really have much choice. Like if you want to store complex values, like you've probably got to store them in JSON anyway. But if you're talking about an RDBMS like MySQL, you've got the question of like, well, do I break my stuff up into columns, or do I like stuff everything into a JSON column, like in a single text field? And the similar things apply where reading SQL columns is going to be more efficient than like reading a massive JSON blob and then having to extract all the values.
Yeah, that totally makes sense. Well, it's good that Presto supports all these different data sources, right? So you can choose kind of what is best for your use case to store the original data, and then use Presto to query it anyway, right? And like even transfer it over if necessary. So that's super powerful and nice to have at your disposal, so to speak.
Yeah, there's kind of like two paths. There's like the path where I get to choose how I'm storing my data, and then I can make decisions that, you know, make my life easier. Or there's cases where my data is already there and I've got to query it, and I'm stuck with whatever somebody else decided.
Yeah, and like both kind of approaches can be very useful with Presto, and like we've seen like useful solutions for that. Like the webinar we had recently with Suora was quite interesting, where they basically write a custom connector that abstracts their APIs and web APIs completely, and Presto with their connector basically treats their whole microservices architecture as a data source under the hood. So there's all sorts of like very creative ways of working with Presto, and luckily with Presto being open source, you can go down your own path, and we can all work together and making it better. And we constantly have new connectors coming in, right? Like even like in the last couple of months, in the last couple of releases, it was quite amazing to see like the Prometheus connector jump come in, and what other one came in? The Iceberg one is kind of pretty heavily developed at the moment, I know, and there's a couple of others that came in just in the open source releases, and that's very gratifying and great to see how the community is all chipping in and working together.
Absolutely.
All right, I don't know when we started our break. Maybe Mandy can keep us in sync here.
I think you guys are good to go.
All right.
All right.
Maybe David should have a quick sip of coffee or something, and then we'll roll again. Cheers, man. Excellent work.
Thanks. All right, so on to array and map functions. Arrays and maps are very common when working with data in Presto. And like traditional database systems, structured data is less common. Often like people like to normalize things in different tables, and that works well for OLTP systems. But in like big data systems, people don't often normalize because like it's just too expensive and it's difficult to do. And so you'll often have structured data coming in where you've got like arrays and maps or JSON, and maybe you turn that JSON like into Presto arrays and maps. And Presto has consequently a whole lot of functions to operate on arrays and maps. So the first thing we look at is how do we create arrays in a Presto query? So it's pretty simple. You just have you just do array with a bracket, and then you have the values that go into your array. And so here we've got creating arrays of integers and arrays of strings or varchars. So how do you access elements in an array? So we've got an array with values 4, 5, 6, 7, 8, and we want to access the second element, which would be 5. We just say a bracket of 2, and that gives us a second element. Now it's important that to note that SQL arrays start 1-based. Everything in SQL is 1-based. as opposed to most programming languages start at 0. So if you used to, I think used to Hive followed programming languages, so like it starts at 0 as well. So if you're translating queries, it's something to keep in mind. But like everything in SQL starts at 1 instead of 0. So array elements start at 1. And if you try to access a 0 element, you'll get an error. Now there's also, so the square brackets, like that's the standard syntax to access an element. If you access an invalid subscript, like if you access something beyond the end of the array, or you pass a negative, the query is going to fail with an array subscript error. There's also the element at function, which lets you access. You also pass in a position, so we can access the second element here. You can access elements from the going from the end of the array. So if we say access the second to the last position, that would be element 7 in the array. Element at is forgiving in that it will, if you access elements outside of the array, you get back null as opposed to failing the query. So this can be helpful, like if you don't know what size the array is and you only return the value if it exists, you can use element at instead of brackets. One thing to note is that accessing element 0 is still an error with element at. Like 0 is just like, because SQL's 1 based. If you're accessing 0, you're probably just doing something wrong. So it's still an error with element at. But otherwise, element at lets you access stuff outside the array without failing the query. One thing you might want to do is sort an array. And as we saw previously with Lambda functions, we can use the array sort function to perform arbitrary sorting on an array using our own logic. And so let's say we have an array of strings, and we want to sort that array based on the length of the string within the array. So we have our Lambda function that takes 2 elements to compare. And the Lambda function is supposed to return -1 if x is less than y, 1 if it's greater, or 0 if they're equal. And so we use the case expression that we saw previously where we say, if the length of x is less than the length of y, then it's -1. If it's greater, if the length is greater, then we return 1. Otherwise, we return 0. And so this is the comparison function that the array sort function uses to sort the array. And we see here that we get A, Z, B, because these are all length 1. We get BB, which is length 2, and XYZ and ABC, which are length 3. Now, one thing you'll note is the only thing we compared was the length of the elements. So we said, hey, if they're the same length, then they're equal regardless of the contents. And so we know in the array, we have A, Z, and B in this order. And that's the same order that they came out in here because we said that they're equal if the length is the same. An array sort uses a stable sort so that elements that are equal do not get rearranged in the final output. So that's why, because we said these things are equal, they came out equal in the final output. Same as XYZ would normally come before ABC, but because we said that they're equal and because it came before it in the input array, it came out the same order in the output array. Another thing you often want to do is say, do matching against various elements of the array. So we can say, do any, all, or none of the elements in the array equal 8. So we have an array of values, 4, 5, 6, 7, 8. We can say, okay, do any of them equal 8? So we pass in, any match takes the array, and then takes a Lambda function with a single parameter where the array element, and then our expression for the Lambda expression is E equals 8. So we say, do any of the elements match 8? And then we see that it's true because one of them does. We say, okay, do all of them match 8? And the result is false because there's definitely elements that do not equal 8. And then we can say, do none of them match 8? And also the answer is false because one of the elements does match 8. And so this can be pretty powerful for doing like arbitrary comparisons of your array elements because The Lambda expression is run for each element inside the array. And so you can just in a single, very short expression, you can see, like, run a comparison across all of the different elements in the array. And that's the power of Lambda functions, that it lets you do like this inline logic applying the same expression across multiple things. Another thing that we can do is we can filter values in an array, so that we can take an input array and return a new array with only the elements that match the filter. So we've got an array with 5, -6, null, and 7. We can say, give us an array where we only have elements that are greater than 0. And so we get this output of, we only get elements 5 and 7. We know that null, if you say, if you compare with null, so x would be null for this expression. We would say null is greater than 0. That's going to return null, because anything compared with null is null. And then that's going to be treated as false by the filter function. And so that element would be excluded. And then we could say, for another filter, we say, give me all the elements in the array that are not null. So our expression is x is not null. And then we can see here we get 5, -6, and 7, but not the null value in the array. And so this is filter is a pretty powerful way to let you trim down your array to only the stuff that you want. And actually filtering out nulls from an array is also common, because you want to process an array, but you want to exclude the null values, because nulls, as I said before, like nulls have special behavior, and you have to be careful around them. Another thing you can do with an array is you can transform the values into another value, even of a different data type. And so we can do here is we've got the same array, 5, -6, null, and 7 from the previous slide. And our function for the first one is give us an array that has the absolute values of everything else, or give us an array where each value is absolute value. And so we get back all the positive, and that gives us all the positive values in the array, or all the values as positive in the array. And so our output of this is 5, the -6 becomes 6, because that's the absolute value. The null stays a null, because null applied to absolute value is still null, and then 7. And then another thing is, give us an array where all the values are squared, multiplied times themselves. So it's x times x, and that gives us 25, 36, again null, and 49. And we could have done something else, like we could have casted these to a string, or turn them into another array. If you could convert an array to an array of arrays. You can do lots of things with the transform function. Another thing you'll often want to do is convert an array into a string. And so our first example is we use the sequence function. The sequence function generates you an array of numbers. So we'll get an array of 3, 4, 5, 6, 7, and then we pass it to array join. That takes an array, and then it takes the string to use to combine the array elements together. And then we see that we get 3/4/5/6/7 as a string. And so this could be a comma, this could be a multi-character string, anything you want. And this is pretty useful when you want to produce like various output, or like combine it with other string functions. We can see a more complicated example of this. We've got an array with these large numbers here, and which we'll select out here. You can see this is what the array looks like, and we want to transform the values in the array. So the first thing that we're going to do is we're going to use the format function that we saw earlier to convert the integers into strings with commas. And so we'll convert it first into 12,345,000, etc., or 987 million, comma, and so on. So we transform the values into strings with commas, and then we join it together with space/space, and then that gives us our output here. And so, like, using join combined with transform, combined with format, like you can do a whole lot of powerful things to produce like output for a report. Now, another thing that you often want to do is you want to effectively apply an aggregation to an array. So you want to say, take the array and combine all the values somehow into a single output value. And so you can imagine, as before, we showed that you could use the reduce ag function to compute the product of all the values in a column. You can do the same thing at an array level to produce the product of all the values in an array. So if we have an array 1, 2, 3, 4, 5, and you want to say, what's 1 times 2 times 3 times 4 times 5, which is 120, we can use the reduce function for that. So it's similar to reduce ag. It takes the array as input. It takes the starting value for the reduction. It takes a lambda expression that's going to be applied to the starting value and then each value in the array. So we'll start off with 1 here, and then our expression is a times b. So we'll start off with 1 here. We'll multiply it times the first item in the array 1. That'll be the result of this. 1 times 1 is 1. Then we'll say 1 times 1 is 2. That'll be our new value. And then we say 2 times 3 will be 6. That'll be our new value. 6 times 4, 24. And then times 5 is 120. And then similarly to reduce, we might want to transform the output of that into something else. So we've got this final function that will take the output and transform it into something else. In this case, the final output of our multiplication is the output that we want. So we use the identity lambda expression. Just the input is x, the output is x. That's the identity function. And so we get the product of our, we get the result of our multiplication, the product of 120. And so this lets you do basically arbitrary transformations to arrays to transform and combine them into a single output value. So it's like basically lets you do an arbitrary aggregation on an array and return it as a single scalar value. Now, another thing that you'll often want to do to an array is you'll want to transform it into columns. So if we have an array of strings, cat, dog, and mouse, we want to unnest it, which is transform it into rows where each element becomes a single row in the output. And so now the output of our query is 3 rows, each with the value from the array. So cat, dog, and mouse. And this lets you do, now that it's transformed, now it's a standard SQL column, and then we could do other things like you can apply an aggregation to this column, or join it to something, or anything you wanted to do because it's now just a regular SQL column. When you're unnesting, you also might want to know what position was it in the input array. So the with ordinality clause lets us do that. So instead of just getting back the value from the array, with ordinality gives us its position within the array. And so the ordinality goes at the end. So we say unnested as name and ID, and then we select them out in the opposite order so that we select out first the ID and then the name, which gives us our output of the query. So along with arrays, maps are very useful. Maps are a little more difficult to create because they've got keys and values. And so there's 2 different arrays, and they can be different types. And so there's 2 different ways to create maps. One way is we use the map function, which takes an array of all the keys and then an array of all the values. And so you'll get a map here where the first value in the key array is the first corresponds to the first value in the map array, in the value array. And so X goes to 123, Y goes to 456, as we see here in our output. The other way is we can use the map from entries function, which takes an array of row values. All the row values have to have the same data type. So we have a row where we've got the key X goes to the value 123, the key Y goes to value 456. And these, it gives us the same output map as this. This can be a little more easy to read because we can see that the keys and the values are right next to each other. Although like there's a little more like boilerplate to get it started, but it's easier to read because they're next to each other. Whereas like as this one, they're not next to each other, you've got to see that they correspond, but it's a little shorter. And in some cases, if you have separate arrays of keys and values, the map function can be useful. So we access map elements very similar to the way that we access array elements. We use the bracket operator, and we pass in the key instead of the ordinal number. And so if we've got our map of ABC and XYZ, we can see that we can access key XYZ here and get out the value for it. It's important to note that as with arrays, accessing an invalid key with the bracket operator fails with key not present in the map. So similar to arrays, we can use the element function, which allows you to access missing values and it will return null. So here, like the key bad is not in the array or is not in the map, so it'll return null. Whereas like ABC is in the map and you get the same value back just as if you'd use the bracket syntax. Similarly to arrays, you might want to unnest a map, turn it into rows of columns. And so we've got our same map as we had previously. We've got ABC to 1, 2, 3, XYZ to 4, 5, 6. We can unnest it into a key column and a value column. And so here we can see that the map has been flattened into rows with one row for each entry in the map, ABC and XYZ. And you can also use with ordinality, just like you can with arrays, although it's often less useful. Okay, that's everything for arrays and maps. There's a lot more stuff I want to present, but we don't have time. Definitely check out the array and map function chapter in the documentation because it lists all the functions and has a bunch of examples.
There's a quick question we might want to just quickly tackle now, and that is how can unnest operation be reversed partially? So like an array of 1, 2, 3, 4 to go into 2 subarrays. Not sure if that's possible.
Depending on what you want to do, you might be able to do a group by in an array ag. But
so you have to combine multiple functions or something like that.
Yeah, going back the other way can be more difficult. Mm-hmm. But if you can ask on Slack, like with the specific example, I can tell you how to do it.
Awesome. Hope you heard that, Asha. Thanks.
Okay, so moving on to window functions. Window functions are a very powerful feature of SQL that let you do things that you can't do any other way. Window functions are part of the SQL standard. A lot of database systems support them now. Although like that wasn't like MySQL recently added them, but it's a recent feature. They didn't used to support them. Same with SQLite, they recently added support for window functions, so they're like gaining popularity. This is going to give you an overview of how they work. Window functions are very powerful, but can also like very complex and confusing. So there's a lot of tutorials online on how to use them. So definitely like search around once you get a taste of like how they work. So window functions run on the output of the query, and that's why they're so powerful. Normally in a query, you process the from and the joins, and then you process the where clause to filter out rows. Then you process group by and run aggregations, and then you run the having clause to filter out rows based on the results of aggregations. And that's effectively, you can think of that as like the output of the query, or almost the output because like you can use the select clause to drop columns, but that's the output of the query that's going to be going into window functions. So after you do all this, then window functions run, and then you have the select clause to do any final like expressions or renames or like dropping columns. And then you have distinct order by and limit, which run like way at the end after that. But window functions, like it looks like they're in the middle, but you really think about them as like running at the end as like the last, as more or less the last step. So a very common thing you want to do is assign a unique number to every row in the output. And so we have a region table with these 5 regions. We want to assign a unique number to each of the regions in order of the name. And so we say row number, it's called like a normal SQL function, with the, but it's a window function, so it has a special over clause here. So it says the row number function runs over, and then in here we have order by name. So it says process the rows in the output in this order. And so in the order of name. And so we can see that we assign 1, 2, 3, 4, 5 to the rows. Seems pretty simple. We can also make the order by clause. We can order in the descending order of names. So the row number will run over in the opposite order. So starting with M, we get, M is 1, E is 2, and so on, down the opposite order of the previous query. And then even though this order by is descending, we still sort the output of the query in ascending order of names. So that's why like the numbers go in reverse order than the order that we assign them. So the order by clause here for the window function is unrelated to the order by clause for the query, which is because this one is determining the output order of the rows of the query. This is determining the order of that this is determining the order that the rows are fed into the window function. So we can see here again the relation to order by and limit is where we run the row number in descending order. And then we say we order the output rows of the query and limit it by 3. And we see that we got the first 3 names in alphabetical order, but they had the numbers 5, 4, 3. Like we didn't get 1 and 2, even though we know that the row number function it assigned 1 and 2 first because it always starts at 1. They were dropped by the limit. So the row number function ran over the entire output of selecting from the region table, assigned all the numbers, and then we chopped off the last 3 items in the final output of the query after the row number function ran. Now, related to row number, we often want to assign a rank to rows in the output. So like row number, we say order by rank. Sorry, we say run rank over order by name descending. So we assign the ranks in descending order. Well, we get the same output that we had previously from the row number function of M gets the first one, E gets the next one, and so on. And because we're ordering by name, every name is unique in the order by clause, so none of them were tied. They all get unique ranks. But now what happens if we have a tie? So in this case, we're going to order by just the first letter in the names. Well, okay, like we've got 3 values with the same first letter A, and then we have unique E and M. And so because these 3 rows are tied in the order by clause, they all get the same rank. They all get the same rank. They all get assigned rank number 1. And then because we skipped ranks 2 and 3, the order by function assigns the next ranks 4 and 5 to these values because we skipped positions 2 and 3 with the ranking by giving these guys the tied rank. And similar to rank, you've got the dense rank function where we do the same thing where we want to order by just the first letter, so we've got ties. So these all still get rank 1, but because it's a dense ranking, it doesn't skip any values in the output. So this one gets ranked 2 and this one gets ranked 3. So similarly, we saw what happens if there's ties. Well, if we do rank and we give it an order by of null, everything's going to be tied. Or if we don't give it an order by clause at all, they're all tied. And so everything gets the same rank. They all get ranks of 1. But that's in contrast to the row number function where, if we order by null, everything's tied, or order by nothing, or there's no ordering, everything is tied. Row number always assigns unique values. It's just gonna arbitrarily assign a rank, it's arbitrarily gonna assign a unique number to everything in the output. And there's no guarantee that like Africa got row number 1 versus like Asia got row number 3. Just depending on the order that the query runs, like if you run this multiple times, you might see different row numbers because they're assigned arbitrarily because they're tied. Now, arbitrary doesn't mean random. It could be that you run this query 100 times, you're going to get the exact same output. And now you go make a change to the cluster, maybe you add a machine, you remove a machine, you make a config change, and now you run it again and you get a different result. It's arbitrary just based on how the query is executed. It's not random, it's not deterministic. It's just depending on how it happens to execute, you're going to get different results. So if you use your row number, like typically that's what you want, is like you don't care, you're just saying, give me a unique value. But if you actually care about like what happens when there's a tie, you want to use rank. So another thing that we can do is we can assign rows into buckets using the entile function. So if we want to take all the rows and assign them into one of 3 buckets, we use entile, pass it 3 for 3 buckets, and we say assign the buckets based on the order, based on the name order. So we see that the first 2 items get assigned to bucket 1, the next 2 items get assigned to bucket 2, and then the last item gets assigned to bucket 3. And we notice that we have only 5 input rows, but we have 3 buckets. So there's 2 leftover buckets. The leftover buckets get assigned at the beginning. So that's why the first 2 buckets have the extra item in there and the last one doesn't. And so the entile function, like bucketing, can be useful if you need to divide the data up into different groups based on different orders or whatnot, based on different orderings. And another thing that you can do is you can assign a percentage ranking to rows based on where the row is within a given ordering. So if we take the names, we order them by the name, and we say where does it fall within that ordering. So the first name is at the 0%, the last name is at 100%, and then the rest of them are divided across the percentages. So there's 5 items, so you get 25, 50, and 75%. If we had more items, the percentages would spread out accordingly. So everything that we've talked about so far for window functions has been over the entire result set. But what you can also do with window functions is you can partition it so that the window function only runs over a subset of the rows within the output. You can think of partitioning as similar to group by, where like in aggregation with a group by, you're dividing it up based on the grouping columns. With partition by, you're dividing it up based on the partitioning column or expression that you provide. So if we say we want to divide up these regions into by the first letter in their names, we say partition by the first letter. So we'll partition on A, on E, on M, and then we'll order it by name. The ordering is within the partition. So all the A's will go together, and then they'll get ranks 1, 2, 3 based on that ordering. And then the E, there's only 1, so it gets rank 1, and the M, there's only 1, it gets rank 1. And so effectively, you see that like the rank starts over for every partition because it only runs over each row's partition. And you always think of window functions as the window function is processed for each row. And each row has some number of rows that the window function is is looking at. And again, similarly to ordering on null or not ordering at all, if you partition on null or you don't partition at all, it's the same thing where it runs over all the rows in the output, because you think of it as partitioned by null, there's only a single partition. Order not having a partition, there's also, you can think of it as having a single partition. And so like the rank function, because we gave it a non-tied ordering, everything gets a unique rank. There's a single partition, so it runs over all the rows. So window functions are powerful because they let you look at a window function is evaluated for each row, and they let you look at the rows within the output of the query. And so for each row, you can look at values ahead or behind of the current row. And so if we think of, okay, so like for the America row, what name is behind it in the ordering? So if we take the names, or we take the rows, we order them by names, and we say, for this row, what row is lagging it, or what row is behind it? The row behind it is Africa, and the row ahead of it, what row is leading it, is Asia. And so we go to Asia and we say, what row is behind it? We get Africa, or for what row is behind Asia is America, what row is ahead of Asia is Europe, and so on. And then for the last one, what row is ahead of it is null. And for Africa, what row is behind it is null, because there is no row behind the first one, and there's no row after the last one. And these let you do things are pretty powerful, because you can do calculations where, like this Asia row, you could take into account values from the row behind it or values from the row ahead of it. And so lag and lead it's always one behind or one ahead. But you can also you can explicitly pass in the number of rows that you want to look ahead or behind. And so here we do the same thing. We pass in 1, which is the same as not specifying it, and then we pass in a value that is the default when there is no matching row. And so for Africa, the row 1 behind it there is nothing behind it. So we get back the string none that we pass in here. Same for Middle East, there is no row ahead of it. We get back the row none. And we can look ahead or behind multiple rows. And so if we look back 2 rows, both for Africa and America, there are no rows behind them, 2 back. And for Europe and Middle East, there are no rows 2 ahead of it. And then Asia, the row 2 back is Africa. The row 2 ahead is Middle East. And now what happens if we have nulls in our input data? So we've got our table here. We've got IDs 1 through 5, and then we've got A, B. We're missing C, it's a null. We've got D, and then we're missing E. And so, okay, what happens if we take the lag? So for row B, A is behind it because there is an A. There is no row ahead of it, or there is a row ahead of it, but the value is null. So lead gives us back null. Same with D. D has a row ahead of it, but the value is null. It has a row behind it, but the value is null. So lag and lead gives us back null, which is the same that you get if it's at the beginning or the end, and there is no row ahead or behind. But sometimes we don't want the nulls. We want to skip the nulls. So you can use this ignore nulls column, or sorry, this ignore nulls keyword before the over clause to say lag ignore nulls over, or lead ignore nulls over. And so on row B, the row ahead of it is null, and the row ahead of that is D. And so the lead of B ignoring nulls is D, because we ignore the null and we get back D. And for the D row, the row behind it similarly is null, so we get back its lag is B. The row ahead of it is null, and then there's none further on that, so its lead is going to give null no matter what, because we ignore the null and then we skip on to nothing because there's nothing ahead. And so ignore nulls can be a very powerful technique when you're like ordering on something and you want to skip missing values and keep going until you find something that exists ahead or behind. All right, so all the window functions that we looked at previously, they operated on all of the rows in the output or in the partition. But the reason that window functions are called window functions is that there's actually a sliding window for each row that certain window functions can take advantage of. And you think of there being a window frame for each row that specifies what rows the current row can see. And there's two types of frames, two types of frame types. There's the rows frame type, which is physical based on an exact number of rows. And so you can say for the current row might have some number of rows behind it and some number of rows ahead of it. And you'd specify a frame like this. You'd say rows between 2 preceding it and 2 following it. Or you could also say rows between unbounded preceding and current row, which would be everything behind it and just the current row. Similarly, you could say 3 rows behind it and unbounded following, which would be 3 rows behind and everything to the end. Or any combination of these. There's also the range type, which is more of a logical frame type that includes all the rows that are tied with the current row within the ordering. And so you could say range between unbounded preceding and current row, which will be all the rows behind it, the current row, plus all the rows that are tied with it, the current row within the same ordering. Or you could also do the other way where current row, including all rows that are tied plus all the rows to the end. And we'll see some examples of how that works. The first value function lets you access the first value within the window frame. And so if we say the frame is ordered by name, and then rows unbounded preceding and unbounded following, that's all rows in the output, because it's unbounded preceding, unbounded following is everything. And so the first value for every row is going to be Africa, because every row sees all rows in the window frame. Similarly, the last value function gives you the last value in the frame, and every row sees Middle East because every row sees all values in the output. The nth value function is similar. It lets you take the nth value within the frame. And so if we say, give us the second value, because you remember that SQL is 1 based. So 1 would be the first value, 2 would be the second value. Every row sees every row sees all values in the window frame. So the second value for every row is America. Now we're going to look at what is the difference between rows and range. And so this looks pretty complicated, but mainly because like the way that you write the window clause, it's just a lot of words. So we say, for the first one, we've got our table, we've got IDs 1, 2, 3, 3, 5. So it's important that there's a duplicate here, 2 3s, and then A, B, C, D, and E as our value. And our function is going to be take all the values like the A, B, C, D, and E and put them into an array. And this will let us see what values are in the window frame. And so we order by the number. And so remember, we're going to get a tie here, and we'll say rows between unbounded preceding and current row. And so for the first one, that window frame, the first one is only going to be A, because it's all of the rows before it in the current row. and then A and B, A, B, and C, and so on. And so each row just sees all the rows itself and all the rows behind it. Because rows ties don't matter. It's only its physical position in the output. Now, ordering by ID with range, on the other hand, current row includes all the values that are tied with it within the ordering. And so this one sees A, this one sees A and B, and both of these that are tied in the order by ID, current value includes C and D, because even though this row is before it, logically it's not really before it because it's tied here, and so it will see A, B, C, and D. So both of these return the same thing because they're tied with the ordering. We can see if we don't specify an order by clause for rows, it doesn't matter. We get the exact same thing. It's just actually like arbitrary what order the rows are going to be fed into the aggregation function. But we don't specify an ordering for range. Current row includes everything because all rows are tied in the ordering because there is no ordering. And so every row sees all rows in the window frame. And so we saw like array_aggr is an aggregation function. Any aggregation function can be applied as a window function. So we can see that we've got our values 1, 2, 3, 4, 5. We can do a sum. If we do a sum of over nothing, we get a sum of all the rows in the table. And so every row will get the sum of 15. If we say order by V, rows between unbounded preceding and current row, that lets us do a rolling sum, where each row is only doing the sum of all of the rows before it and plus itself. And so like the sum of 1 plus 2 is 3, 1 plus 2 plus 3 is 6, 1 plus 2 plus 3 plus 4 is 10. And so that this sum here, let's just do a rolling sum across the entire table. And you can also combine these. You could say sum as a rolling sum divided by sum over nothing as a total to see like what's the rolling sum divided by the total in the table, to like say what are the percentage of this value, like what's this row's percentage up to this position in the table. You can also combine these with partitioning, and so the window is only for rows within the partition. So we've got our table of, we've got 3 A's with 1, 2, 3, and 3 B's of 4, 5, 6. We partition on P, so we'll get a partition of A's, and then a partition of B's, and then we say rows between unbounded preceding and current row, and we do that rolling sum again, ordered by V. We get the sum 1, 3, 6, which is 1 plus 2 plus 3. And then we get the rolling sum of 4 plus 5 plus 6 here. The rolling sum starts over because it's a different partition. So the window functions are evaluated separately for each partition.
Wow, that is crazy stuff, man. Unbelievable what you can do in Presto with SQL and advanced functions. Some of these later things remind me on like writing Fibonacci series or stuff like that in math expressions in SQL, which is like a totally different syntax, but can achieve some of those same kind of things. So that's amazing. I hope nobody's brain completely exploded today. Catching up and holding in there with David is truly a tough job. As you know, he knows the stuff in and out. And luckily, in the next couple of weeks, you'll have a chance to learn even more from some of the other co-creators of Presto. So if you want to jump to the next slide, you'll see in our Presto training series, we're going to have 3 more events coming up. One with Martin, talking about understanding and tuning that query processing. Now that we know, and we also talked in some of the questions about performance implications and how to write these queries. The next step, of course, is making sure that your cluster can also deal with that workload that you're throwing at it, right? So how do you look at the explain plan of a query, see what's going on? How do you tune that happens as quick as possible so your users love Presto as much as you do and want you to scale up your cluster and use it even more? And then, of course, with getting more users on board, what's going to happen is that you're going to have to connect more data sources, and it's going to become more and more critical that you secure Presto, right? The access to it should be secured on the front end, but then also the security down in the cluster and down to the data sources. And Dane is our top-notch person there, knows everything about the security in Presto, and he's going to talk about that in August. And then we'll talk about the Presto performance of the overall cluster with Dane again in September. So 3 awesome training series events still coming up. So stay tuned and make sure you register for those. Of course, we also have some other events happening. Some of them are already over. In the Presto Summit series, we already had the State of Presto with Piotr, one of our core maintainers, as well as David, Dane, and Martin, where we talked about what's coming up for Presto in the future, things like the function support we talked about, and a whole bunch of other things. Should be very interesting for you to check out. The recording is already available. Same for the usage of Presto as a query layer to the microservices architecture at Zuora that Henning presented a while ago, and then the massive Presto migration that ARM Treasure Data did. Both of those are also available as recordings, so check them out. They're all on the prestosql.io blog. And on the 19th of August, I have the pleasure to host 2 users or / developers, Presto owners from Pinterest, and they'll talk about how Pinterest is using Presto in their environment. So lots of interesting stuff to come still. And of course, this is not the end of it, right? You can learn more from prestosql.io. You can join us on our PrestoSQL Slack, get a free copy of the book, as I mentioned before. And thank you for hanging out with us, and see you next time. We're still going to do a bit of a Q&A section now because lots of questions came in. If we don't cover all of them, please make sure that you ping us on Slack. So let's dive right in, David. There's a whole bunch here. I have to scroll through. So a bunch of them flew in the beginning when we talked about JSON. So one of them was, when you do this partial parsing of JSON where you parse the whole JSON object, what if you want to just like return one of them, like just the name, for example, rather than like basically parsing the whole document and accessing everything and mapping everything out if you just want to access one of them?
So JSON extract is what you want to use for that. JSON extract lets you access just a single like nested element within the document.
Okay, that's one of the other JSON functions. There was another question that came in around JSON that I put a link into the answers there, but you can easily find it in the documentation, by the way. Related to that, also a question came up if there's any functions to update the JSON, and I don't think there is, at least from what the documentation I saw.
No, you would have to either like extract it into a string and do string manipulation, or turn it into a Presto data structure and then use like say, like for example, like the array transform function lets you transform values inside of it, and then you could turn it back into JSON.
Yeah, so it gets
pretty hairy. There's not great support for like directly modifying things in JSON.
Yeah, so that was the question from Stefan. That was great. Another question that came up a bunch of times is there any analog of a lateral view like in Hive in Presto? And I think there came another question related to that with JSON as well.
Yeah, Presto has the lateral keyword. Often what you're doing with that unnest, I believe is equivalent to Hive lateral view. But we also have lateral that lets you do more things like access values that you're joining against on the right side of the join. But if you check the select documentation and the select statement documentation in the Presto docs, those are documented extensively.
Cool. Asha has a question that talked about the approx percentile function, if it can ever return, like if there's ever a situation where the orders are wrong. For example, he's saying approx percentile of X in 0.9 is less than approx percentile in 0.5. I don't know, but I'm thinking that's totally possible, but that's not wrong, right?
I'm not sure about that. If you could ask on Slack, we can dig into that. but I don't think it's possible based on my memory of the data structure, but
yeah, might have to dig in. So make sure you jump in. Now, another question from Arno was, can you explain more about the Elasticsearch connector? If I do some aggregation, is this done on Elasticsearch cluster using index or Presto pull through raw data and do all processing at the Presto workers? I can a bit explain that, I think. So there's been some recent improvements on the Elasticsearch connector, and the Elasticsearch connector is very powerful because it can kind of do both. It does query the Elasticsearch cluster and understand what nodes there are, and it offloads a lot of processing to them and even does them parallel, but then it also does a lot on its side. Where the balance there is, I'm not sure.
So we recently added support for aggregation Presto, or aggregation pushdown in the Presto. Not all connectors have been updated to take advantage of it. I'm not sure if aggregation is possible in Elasticsearch. It might be, or it might depend on what you're doing. One of the issues with pushdown is that, like, Presto has, you can see, like, has tons of advanced aggregation functions, and most systems would not be able to evaluate those because they don't have those functions. Whereas, like, if you're doing like a simple like sum or account, maybe the underlying system could and would be able to push those down, but it depends on the connector. And if you have a question about, like, exactly, is this supported, it's great to ask that on Slack.
Yeah, exactly. I was just going to say also, it totally depends on the connector. Like, one thing that's, for example, special with the Elasticsearch connector is that there's like a funky syntax where it allows you to basically embed an Elasticsearch query string into your SQL query, and then that's passed through raw. So there's all sorts of things, but it totally depends on the connector. And we're more than happy to work with you if there's anything in terms of improvements on the connectors as well. Now, let me see if there's something else that I see. Partial. May the reduce return different type than the input column? That's also from Stefan.
Yes, you can pass. The final lambda for reduce lets you transform the intermediate into a different type of output.
Okay, cool. There's a question about just doing count star for better understanding, but can you substitute with the actual use case? I'm not sure what that is about. Maybe you remember. Or if you want to ask again. Shen is asking, how do you prevent views from becoming stale if the underlying query still works? Don't know how that.
You actually have to recreate them in Presto if the underlying query. So a view becomes stale. When you create a view in Presto, Presto analyzes the underlying query to figure out, like, what the column names and the types are, and then it stores the column names and the types along with the original SQL. And then when you go to access the view, it reanalyzes the query, looks at the column names and types from that, and compares it to what it had saved. And if those two things are different, then it says the view is stale and you have to recreate it. And that's a safety feature, because if you changed, like, the underlying table and now the data types are different, you want to guarantee that you're not running. I'm trying to say here. You don't want to return the wrong result, and that would happen if the underlying table changes in a like non-backwards compatible way with the saved view.
Okay, cool.
And Presto needs the types and the names that it saves in order to when it's doing analysis of the view. So effectively, like, treats those as like the types of the view table.
Cool. Now there's another question again about the JSON data type. That's probably an easy one. Is there like a max size that like the JSON string can be? I'm guessing there is, but it's probably huge based on memory or something.
I mean, we had people that use JSON data types like in the tens of megabytes. Like, that's actually one of the difficulties of a system like Presto is people want to have tables of like billions of trillions of rows with like, integer columns that are tiny, and then you want those to process like extremely fast. And so to do that, you want to be processing, blocks of like thousands of rows at a time. And then other people show up and they're like, oh, I want to process, my 30 megabyte JSON column here. And well, if you have 1,000 30 megabyte JSON columns, like that's way too much to store in memory. So we have to do a bunch of work so that like we can adaptively handle like both of those use cases. And so like, yeah, like the limit's like, say like in the tens of megabytes.
That's pretty big string. Now
Yeah.
There's another question from Vivian. Not sure. It's just asking if the row number function is slower than the rank function. I'm not sure about
no, row number is actually faster, especially in certain cases. Presto actually has specific optimizations for row number that it doesn't even run it like as a window function. It actually runs as a special operator that just very quickly numbers the rows. So
Cool.
rank is slower because it has to deal with ties.
Has the tile. Yeah, fair enough. That's cool.
Or could be slower. It's not always slower, but like row number is definitely the potentially fastest choice.
Cool. Well, hopefully that'll help, Vivian. Probably going to be fast in either case, though. Now, VG is asking a good question. That is, when writing quest to query, do I need to check how the table is partitioned?
Is that? I'm guessing in terms of the Hive connector. You want to know how the table's partitioned so that you can write your query efficiently. Usually, like you partition a table because it's large, and like taking advantage of the partitioning columns to filter on lets you only access parts of the table that you care about. But if performance isn't a concern, then like you don't need to care about the partitioning. You can just run your query and you'll still get the right answer.
I think that's probably also something that Martin is going to cover in our next webinar automatically, because understanding and tuning query processing is all around that, and like getting an explain plan, looking at it, trying to understand and like read what it says and that kind of stuff. So that's also related to the aggregation push down, where you can see in the explain plan if it's pushed down or not, how it scales out across your cluster. There were a couple of questions around that kind of stuff. So I think that's going to be definitely something that Martin will talk about as well.
So you don't have to care, but you might want to care.
Yeah. And what we've also seen in the webinar last time, where we talked to the guys from Treasure Data, that was very interesting, is they have a large deployment, and they have basically an inventory of all the queries people run against it, and they work heavily with their users to make them optimized and that kind of stuff. So as the administrator of the Presto cluster, you will probably care, because different queries will impact your cluster differently. As a user that just clicks in the UI, you obviously should not have to care, right? So it's like both scenarios, and both answers are kind of true. Let me see, there's another question. How can we operate on arrays on S3 HDFS? Is there a way to use Parquet org files for storing and querying an array or multi-value fields and access that using Presto?
Yeah, Orc and Parquet natively supports array and map and row types, and actually those are commonly used. Like people often have very nested data structures in Orc and Parquet.
And in SQL, that just shows up for you, right? Like,
yeah, when you describe the table, you'll see the full nested data type, and you just access it with the array and map syntax.
So that's awesome, right? Like as a user, essentially, you don't care. It just looks like a table for you. That's one of the advantages of Presto. It just like translates everything under the hood and makes it available for you as a normal table structure, which is great.
And for both of those formats, they're columnar, so you only access the fields that you only actually physically read the columns that you're accessing in the query.
That definitely helps with the performance, I'm guessing. Okay. Well, we're getting a bunch of thank yous for showcasing all this cool stuff. Looks like people are definitely interested in more. So we might have to top it up at some stage. But again, please do reach out to us on Slack, jump in there, try Presto out. use the video that we have to play around and hit us up with more questions wherever you can find us. I think that's pretty much it. Oh, there's one that might be interesting. It's kind of an edge case. Bipin is asking, he's asking about having CSV files on an FTP folder. How can I integrate this into Presto?
Presto doesn't have any way to access FTP directly. So there's kind of two things. There's like, how do I physically access my data, and then like, how do I actually like map it into Presto? And so usually for any kind of cases where like I've got some like flat data files, you want to use the Hive connector, because Hive is both like has the metadata component of like, I've got the Hive metastore to store, here's a table, and it's like physically stored like this in like this file format, and then this is where like it physically lives. So you use the Hive you'd use the Hive connector to create metadata about your table, and then you point it at your storage. For FTP, yeah, I don't think there's anything like that. You need to be able to access it through some sort of like distributed storage system like S3 or HDFS or Minio or like any of those. Maybe there's some kind of bridge that could turn like FTP into a, I don't know, like NFS file system or something, but ask on Slack about your specific use case, and we can try to help you.
But the Hive connector definitely supports CSV files, right? And that was also a question that came up earlier. I'm guessing CSV files would be faster to process than JSON files, just because they're already like a table format, basically, right?
It's probably about the same. Like, well, CSV is typically like not nested, or like actually like a CSV column could contain JSON inside of it, but you still have to, like, it's still text where like you have to read the whole thing anyway, even if you only want one column. So yeah, really none of the text formats are like are very efficient. Like Orc and Parquet are much faster.
So in many cases you would do some sort of like ETL load that transfers those from the source CSV file, and that could even be an FTP folder, I guess, that is wrapped somehow with Minio, and then you do a create table as statement ETL process that pulls it over into a Orc Parquet. That's what you can do, right?
Yeah. So Presto lets you query data like where it lives. You don't have to do the ETL, but the ETL can like save you like a lot of time, both in terms of like compute and human time.
Yeah, and that's also a question that came up, if Presto can do these kind of ETL things, and my answer was that yes, it definitely can, and lots of people are using it. The one thing that I probably want to caution people about that though is if you do a lot of ETL stuff and at the same time you do a lot of like real-time analytics, people should probably have separate clusters for those, because the workloads and demands on the clusters are quite different. Is that right?
Yeah, that's good advice. At Facebook, that's what we did, is like we had separate clusters for the batch workloads and from the interactive. And then actually we even had like dedicated clusters for like specific types of like reporting that had even more stringent requirements on performance.
Awesome.
So you can't run everything on a single Presto cluster, but like often different physical clusters just makes it easier to manage, because like you're getting dedicated resources.
Yeah, also if you have different workloads in terms of memory footprint and stuff, you can actually use different like Docker container sizes and whatever else you want, or whatever you're going to use in your cluster, right?
Yeah, like our batch clusters, we actually tuned them they had much higher memory limits. Like we turned up all the timeouts. We tuned them in different ways so that we would maximize throughput. Like since there was these were scheduled queries that nobody was like waiting for the results on. What mattered was that the clusters efficiently processed as much data as possible. It didn't actually matter like how long a given query took, or like whether it like was fair. Whereas like when you've got humans in the loop waiting for the results, like you're trying to optime
they're waiting
the cluster time.
Yeah, you don't want you humans sitting like that going, come on, Presto, let's go. So you want to optimize your query and your processing, and that's a good lead. And I think we pretty much at an end today. So again, thank you very much for joining us. Do join us next time with Martin on understanding and tuning query processing. and make sure you keep an eye out on the blog for the video and the slide follow-up that we'll send out. You'll also get an email with that. So we'll see you next time. Thanks again.
Thanks for joining us.
And I think